Don't forget to subscribe and ring that bell.
Welcome, welcome. Come one, come all, as we continue the 2014 AP Calculus AB practice exam. We are going to finish section 1, part B. These are multiple choice questions 85 through 92, and we get to use a graphing calculator. Nice. Yeah, that's cool. Speaking of graphing calculators, I have a set of TA84 plus CE, the color editions, they're beautiful. The yellow ones for the school sets are kind of, they're okay, but they got a whole slew of personal colors. I have the mint green. Yeah, that's cute. And I put some links in the comments below if you're interested in buying one, if you need one. If not, hey, let's get started. 85. A particle moves along the x-axis so that its velocity at any time t is greater than or equal to 0 is given by v of t equals t squared minus 1 over t squared plus 1. What is the total distance traveled by the particle from time 0 to time 2? There's one thing you need to understand. I need to integrate velocity to get distance, okay? But there are two forms of distance. And let me explain this quickly before we do the problem. There is displacement, okay, and there is total distance, okay? You can see that this problem is asking us for total distance, which I highlighted or underlined in red. Displacement is a normal integral, okay? Normal integral. Our problem is from time 0 to time 2. All right? Displacement is the distance you end up with compared to where you start. So it's the difference in where you started to where you ended up. And if I had a graph, okay, that means anything above the x-axis, this area and this area, are considered positive values. Anything below is considered a negative value. So I would have to subtract and add there. Total distance, it's the same thing. I'm integrating from 0 to 2 v of t dt. However, on my graph, it doesn't matter if I'm above or below. Total distance, I want every step you took or every, movement this particle made, whether it was away from its starting distance or back toward it. I want to add it all up. If I'm adding it all up, that means every area under the curve is going to be considered positive. And I'm going to add it, and that's what we're doing here. Now, I don't have a curve. So how do I do that with integration? One simple difference. I just put the absolute value bars, and that makes everything positive. So I'm going to take my velocity here in the problem and integrate it with absolute value bars. So know the difference, okay? So we're going to integrate from 0 to 2, t squared minus 1 over t squared plus 1 dt. If I wanted displacement, this is good enough. But since I want total distance, I got to put absolute value bars around this. And we get to use our calculator. So let's turn this on. We are going to go to Math 9 from 0 to 2. And I need the absolute value bars. Math. I move over to num. And the first option is ABS. It's not anti-lock brake system for those of you that drive. It is absolute value bars, and there they are. Alpha y equals enter. And let's put in our equation. X squared minus 1 on top and x squared plus 1 on the bottom. Don't forget that dummy variable. I just take every opportunity to say the word dummy that I can. And we come up with 0.927, okay? So that's approximately, on the board here, 0.927, which is choice D. Number 86, line L is tangent to the graph of y equals e to the x at the point k, e to the k. What is a positive value of k for which the y-intercept of L is 1/2? All right. A couple of things I would like to point out here as we start. So let me get my calligraphy pen because I love it. This is a coordinate. This is like my x and my y value. Notice if my x is k, then this right here is e to the x. Okay, my y value is e to the x. And how do I know that? It tells me right here. Okay, so that my coordinate is really this. If I really want to make things a little bit simpler to me, I could just change it if I'd like. All right. The second thing I'd like to point out is in calculus, when we think of a line, an equation of a line, we always use y minus y1 equals m times x minus x1. This is the standard for what we use when we're coming up with equations of tangent lines, etc. I have never come across a problem where I had to use, or should I say it's easier to use, y equals mx plus b. However, this is the first problem, I think, in, oh my God, maybe ever, in the calculus reviews that I've done, where I'm going to use this one instead. How come? They give me the y-intercept. It's 1/2. Okay? In this first equation, I have point, slope. In this equation, I have intercept, y-intercept, which they give me, and slope. So let's go ahead and do this and come up with this equation of a line right now, because we're going to need that to solve this problem. All right, so y equals, I don't know my slope yet, x, my y-intercept is 1/2. Okay? Now, it's easy for us to calculate slope because we know the derivative is slope. Okay? So if y equals e to the x, y prime, the derivative, well, that's still e to the x. So times e to the x. All right, that's good. But it looks like, okay, if we go back to our problem, what's the positive value of k? So it looks like there might be a positive and negative. I want the positive. But the second thing is, I don't have a k here, do I? Let's keep in mind that k is the same thing as x. So if I just solve for these x's, I have my k. So there's one more thing left I need to do, okay? I can graph this line, but it's really not going to help me too much. But let's do this, shall we? Let's do this. This is what comes in handy, all right? I have two unknowns right now. And I'm going to stop using the yellow highlighter because it's not so easy to see. I have a y, and I have an x, okay? I would like just one unknown. I'm going to substitute in for y, e to the x, all right? So write in for this y, it's e to the x. How come? Because y is e to the x. I'll just rewrite this tonight, x times e to the x plus 1/2. Ooh. Now what I have here, I like it. Why do I like this? Because now I'm going to put this one in y1, this one in y2, and see where they intersect. I am almost certain they will intersect at two places, a negative x value and a positive x value. Remember, we want the positive. So I have e to the x, and then I have x times e to the x, plus, I could say 1/2 or 0.5. When I graph these bad boys, this is e to the x, beautiful little function. And this, my friends, is our timid x times e to the x plus 1/2. Two intersection points. One looks like it's right here. That definitely looks like a negative value on the x. And one which is right here. That's our positive bad boy. So let's use the intersect function and find that positive value. Intersect. Da, 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 da. Enter, enter, enter. Okay, look at the bottom. Intersection is at x equals 7.68. I should say 0.768. 0.768. Right there. I go here. This happens at x is approximately 0.768. And that's choice B. That's kind of tricky because we really don't have problems where we're given things of this nature to solve. But every once in a while, you got to do a rare one, just like we did right here. Number 87. A differentiable function f has the property that f prime, okay, the derivative or the slope, has to be less than or equal to 3. So 3 is the biggest my slope can be. Okay? So off to the side here, I can have a slope of 3, 2, 1, 0, -1, and so forth. I can never be bigger than 3. That's an important thing to understand. Okay? So that slope, which is less than or equal to 3, for all x values between 1 and 8 inclusive. And they also give you a coordinate. F of 5 is 6. When x is 5, y is 6. So which of the following could be true? Obviously, it could be true because I could have any one of these slopes, so forth. So let's start with a little table here, x and y. The only thing we know on this table is, okay, we got 1, 2, 3, 4, 5, 6, 7, and 8. Why am I doing that? Because they're telling me x is between 1 and 8. And the only thing I know that f of 5 is 6. That's the only thing given to me. All right? I don't know why that pops up, but I'm getting rid of the smart board, and I'm getting one of those fancy, like, 75-inch television-like things instead of the smart board. I'm going to miss the smart board. I'm not going to miss those windows popping up, but I'm going to miss the smart board. All right, so let's take a look at 1. I'll do this one in blue. F of 2 is 0. Okay, so they're saying f of 2 is 0 right here. Now, if my slope is at most 3, what happens if I go here up 3, right? My slope. This would become 3. Okay, let's say I go 3 more. This becomes 6. Let's say I go 3 more. Okay, this becomes 9. And you might say to yourself, well, no, it's 6. That can't be true. All right, well, let's go backward this time. All right, let's go backward. All right. Keep in mind, I can have any one of these as my slope, as long as it's not bigger than 3. Okay, so what's the difference between 6 and 0? It's 6. Okay, so what if my slope was 2? What if I only went up 2? I could have a slope of 2, can I? It's right here. This would go to 2. Okay, go up another 2 and go to 4. I can go up another 2 and go to 6. So that's a possibility because my slope can be 2. So that's true. All right, let's say, okay, that one's done. I'm going to kind of erase that right now. Let's take a look at that middle one. So I know 1 has to be true. Okay, let's go to red now. This one I'm going to do in red. So 1 has to be true. This could be true. Only 2, no. 1 and 2, okay. 1 and 3, okay. This E does not have 1. So I've canceled B and E. So number 2 says f of 6 is -2. Okay, well, I would have to go down 8 as my slope. I can have -8. I can have any negative number as long as it's less than 3. -8 as a slope is less than 3. So guess what? True. So it's not only 1, choice A. Oh, that's a possibility. Oh, I got to see if, well, no, 2 should be here. I got my answer, it's C. I got my answer, it's C. Now, just for some of you that are like, well, can you explain this one? Sure, let's take a look at f of 7 being 13. All right? F of 7 being 13. Such a small little eraser. Okay, can f of 7 be 13? Now, keep in mind my maximum slope is 3. If I go up 3, that's to 9. If I go up 3 again, this would have to be 12. It can't be 13. This is a false. And how do I know? Because my slope can never be any bigger than 3. All right? It's kind of a logic thing. Easy when you're just counting by 3s. But the choice is choice C. 88. The graph of the differentiable function f is shown in the figure above. God, I love graphs and tables and charts. Let h be the function defined by, okay, h of x is the integral from 0 to x of f of t dt. Which of the following correctly orders h of 2, h prime of 2, and h double prime of 2? All right, let's do this. So we need to find the values of each one of these, then compare them with an inequality, going from smallest to biggest. Let's start with h of 2, which I will do in blue. So h of 2 means I just put a 2 in for my x. So it's the integral from 0 to 2 of f of t. We know that integrals are area under the curve. 0 to 2. This area here, I don't know what it is, but since it's above the x-axis, I know it's a positive value. So h of 2, I'm going to put a positive right here for h of 2. Let's take h prime of 2. We'll do that in green. If I need to find the derivative of h, we'll worry about that first. I need to take the derivative of h, which is 0 to x, f of t dt. All right? Whenever I take the derivative of an integral, these cancel, and bye-bye goes that dummy variable, and my x goes in here. So really, the derivative of h is just f of x. So if I want this at 2, I really just want the coordinates when x is 2. What's my y value? Well, here's a coordinate. That y value is 0. That's 2x, 0y. So that's 0. Okay, so h prime of 2 is 0. So right now, I know h prime of 2 is less than h of 2 because a positive value is bigger than 0. Last one, h double prime. And we're going to use this right here. If the first derivative of x is f of x, well, now, I should have left some more space there, but now I got to take the derivative of these, right? I want the second derivative, which means I got to take the derivative, sorry, I'm writing this on the right-hand side, of this. That's just f prime of x. So the second derivative of h is really the first derivative of f. The first derivative is really just slope. So it's the slope of f. And I want that at x equals 2. So let's say, here's where x equals 2. Where's the slope here? It's downward. That's a negative slope. So this has to be negative value. I don't know what negative, 1, 2, whatever. But there you go. So if I read this right, this is the smallest. This is in between a negative and positive number is 0. And the positive value is the biggest. This is what I'm looking for. Double prime, single prime, 0. Right here. Choice E. Good problem. Good problem. Similar to what we're used to doing. Number 89. What is the area of the region enclosed by the graphs y equals e to the x minus 2, y equals sine of x, and x equals 0? Okay, let's get a visual of this first. Area of the region. Okay, area under a curve or between curves is always an integral, okay? But let's get a visual of what we're integrating. So I'm just going to graph these two functions they gave us, okay, right there. Turn this on. Go to y equals. Let's do second plus. So let's just clear this out, okay? Go back to y equals, and I'm going to put in, for the blue line, e to the x minus 2, all right? And the second line is going to be sine of x. I mean, you should always be in radians, okay? And x equals 0, well, we'll just draw that in a graph. So let's graph this bad boy. And it looks like I'm going to have to zoom in a little bit because x equals 0 is the y-axis. So I want between the y, this is x equals 0, this line right here, and where they intersect. So I'm going to kind of zoom in. Zoom box. You know, this is an underused let's go here. Let's go hit enter. It is an underused function. Okay, I love the zoom box. I can just select where I want to zoom. So I'm going to hit enter. And there we go. So the blue one is e to the x minus 2. And the red one here is sine of x. So I want between. All right, now let's bring this out here so we can draw or something here. I want between. Okay. Right here is x equals 0. And this point. Okay, I got to figure out what that point is. Okay, so I'm going to have to use the intersect function in the calculator. So again, I'm going to go second, trace, intersect. And move my little spider dude, I like to call him, closer to the intersection points, and hit enter 3 times. 1.0541. You can see in the bottom left of that screen. So x is 1.0541 between this and this. So I really want, let's try that, all this area right here. Okay. Remember, when I'm integrating between two curves from 0 to 1.0541, it's always the top curve minus the bottom curve. My top curve is this one here in red, which is sine of x. And I got to subtract the bottom curve, okay, which is e to the x minus 2. And don't forget our dummy variable dx. Now, I like putting top curves and bottom curves in parentheses, because if you forget to put parentheses, you're only going to subtract to the e to the x. You just subtract them both, okay? So please make sure you put parentheses there. Otherwise, it could be for a long day. So let's go ahead and integrate this right now. Let's go second quit. And I really have this x thing, but I'm going to put this value into u. Okay, so I'm going to hit store into u. So anytime I use u, I've got this number that I haven't rounded yet. And I don't like rounding until the end. Okay, so let's math 9. Integrate from, let's go to. Let's integrate from, okay, from 0 to u. There you go, because keep in mind, my u is 1.0, that whole number, okay? Now, it is from parentheses sine of x minus parentheses e to the x minus 2. Close that parenthesis. Dx, don't forget that dummy variable. And we should end up with 0.7447. So that's approximately 0.7447. This would round up to a 5, because most of our answers are 3 decimal places, and it is choice C. Number 90. A particle moves along a line so that its velocity is given by v of t, which is negative t cubed, plus 2t squared plus 2 to the negative t for t values greater than or equal to 0. For what values of t is the speed of the particle increasing? All right, there's one way to do this, which is typical. And there's another way that I'm going to show you particularly for this problem. I'm not sure if your teachers have shown you this or not, but it's a cool way, especially if you're looking at a graph. Now, in order to find out if something's increasing or decreasing in speed, we got to take a look at the velocity and the acceleration. It's called a scalar relationship. If they're both the same sign, my particle is speeding up. Speeding up. If they're opposite signs, much like multiplication, it's negative, so it's slowing down, not speeding up. Okay? Well, when you got to take, sometimes people forget the derivative of this. It's not common in a calculus AP to take the derivative of an exponential like that. Now, I can do this just by looking at the graph of velocity. And that's what I'm going to show you right here, without having to actually evaluate for acceleration. All right? So let's go ahead and take a look at that. Let's graph what they gave us for velocity right now. Okay, it just says t greater than or equal to 0. Okay, that's fine. And let's clear this out. Go to y equals. Clear, clear. And we got negative x cubed. Okay, plus 2x squared minus, plus 2 raised to the negative x. Oh, behave. All right, negative x. Now, I suppose if you had a difficult, no, we'd still have to do it that way. Never mind what I suppose. Now, my window, my time is 0 or greater. Okay, so which is my x value. I'm going to make that 0 to, I don't know, let's go to 8 by 1s. In y, we'll go negative 8 to 8. Hopefully that captures everything we need. We can adjust the window if we need to. All right. Okay, this is good. That's fantastic. What I'm going to do now is I'm going to zoom in. I really don't need anything more than 1, 2. Let's go to like 2.5 on the x, or on the y-axis. So let me go back to my table, my window. And y, we can really go from negative 5 to 2.5. Let's see what that looks like. So I'm trying to get, okay, that's what I wanted to see. You see how there's a little dip down here? You need to be careful. This is going downward, right? So what do I mean when I say we can, you know what, even on the x-axis, let's see if we can even get more. I don't have to go farther than 3. Sorry, I'm being particular here. Let's go to 3 as a maximum. Okay, so it's a little bit more pronounced now. It comes down, then it comes up, then it comes down and goes down forever. 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 So I'm going to take this graph. This is v of t, all right? So remember, if we are talking about velocity here now, okay, if we're talking about velocity, which is my y is velocity. So my velocity is 0 right here. What do we know about that? If my velocity is 0, I am stopped here, okay? So if I want to know whether I'm speeding up or slowing down just by looking at the graph of velocity, if this x-axis is a speed of 0, anytime I'm going away from the x-axis, I'm speeding up, okay? When is the speed increasing? Anytime I'm going away. Anytime I'm coming closer to the x-axis, I'm slowing down because I'm approaching a speed of 0. Does that make sense? It's really easy. So for example, I'm looking at this graph. This looks like it has a slope of 0 right here. Slope of 0. I am going, since this is a negative slope, I'm moving down toward the x-axis, so I'm slowing down. Since this is increasing, I am moving away from a speed of 0, which means this is where my speed is increasing. Call that SI, all right? Now, I'm going toward 0 right here, so my speed is decreasing. But look what happens when I pass my 0. I'm getting further and further away from 0. If that doesn't make sense, let me explain it this way. Even though this is a negative value, when it comes to velocity, if it's negative, that just means direction. So I'm moving away, okay? I'm moving away from 0, so I'm speeding up, moving to the left. That's all it means. That has nothing to do with speed, but direction, okay? When I look at this one up here, okay, it's positive. It's above the x-axis. That means I'm moving to the right and speeding up. This means I'm moving to the left and speeding up. Okay, so anytime I'm moving away from the x-axis, that means I'm moving away from a speed of 0. That means I'm speeding up. So all I've got to do is find this minimum point and find this maximum point. Between those 2 points, I'm speeding up. Then I got to find the 0. And anything after the 0, again, I'm speeding up. So let's find some points. Second, trace, let's do a minimum. I think the explanation is so much more time consuming than the actual math. So again, I want to find this minimum point right here. Let's go here. Enter. Do our little bookends. Enter. Hit enter one more time. This minimum is 0.176. So let's find this maximum. Second, trace, maximum. Go up here. Enter. Enter, boom. 1.256. So we got, rounding, this is 0.177, okay, to 1.256. So between this, I'm increasing, moving away. So it's got to include this. Yes, yes. No, it's not this one. No, it's not this one. No, it's not this one. And we know it's not only that. It's also got to include this, which guess what this 0 is if I do it? 2.057. This 0. So anything bigger than 2.057. Guess what? My option? Choice E. Number 91. 2 more problems left. Let f be a function defined for all real numbers x such that f prime of x is greater than 0. That means it's increasing. And f double prime of x is greater than 0. That also means it's a happy face. So not only is it increasing, but it's increasing at a smile. It should look like this. Okay? So all I'm going to do is kind of just figure this out. I'm just going to look at these points and figure out which could be the table for f. All right? So this goes from -3 to -4. It's actually decreasing. This is going to be going down. It can't be this one. Okay? B. I start at 1, -3, and I go up by 2. Okay, then I go up by 4. Then, oh my God, I go up by 16. So if I start here, I go up 2, I go up 4, I go up by 16. There's my curve right there. Choice B. The rest of these, if you do them, this is just a consistent, the same amount. 3, 3, 3. So that's just going to be a straight line. D, it goes up by, what's that, 8? But then it goes up by 6, and then it goes up by 2. So it goes 8, 6, 2. That's actually a sad face. It increases, but it's concave down. And this one just goes down and up. That's just, I don't know what the heck that is. But it's choice B. Number 92. Oh, graphs and tables and charts. Oh, my. I love them. 92 says, let me get this down here a little bit. Give us a little bit more room. The table above, love it, gives values of the differentiable function f and g, and f of prime, the derivative of f, at selected values of x. Now, g of x is the inverse of f. So anywhere I see a g, I am going to substitute in this for my sanity. Okay? So what is the value of g prime of 4? Isn't g really the inverse of f? So if I want the derivative of g, I want the derivative of the inverse of f. Where? At 4. Anytime I do this, I am looking for, okay, my rule for solving for the derivative of an inverse is 1 over the derivative of the inverse at our value 4. And once I figure out the inverse, which is it's not hard, it's the hardest part of this problem, but it's still easy. Once I get that, the rest of this is cake. And we don't even have an equation we got to manipulate. They give us values. Yum, yum, yum. So let's start by finding this right here. And you need to know your rules about inverses. Okay? This is a coordinate. Okay? X and Y. I don't have inverse in my table, but I do have F. Okay? So what this tells me is, if I look at my original function, comparing inverses to originals, the X's and Y's switch. Okay? So this will be 4. So if I look at my original, and this is what I'm trying to solve for. So if I look for my original F here, where's my output of 4? Right here. What X value makes that happen? -2. -2. So if -2 is here and they switch, guess what? -2 is here. That's the hardest part of this problem. Okay? So my inverse of 4 is actually -2. So my inverse of 4, -2 is going in right here. So now I just want 1 over the derivative of f at -2. Here's the derivative of f. When x is -2, it happens to also be 4. So this happens to be 4. So it's 1 over 4. Oh, goodness, great. I love having nice, simple problems to do. I really do. And you know what else I love? We're done. I don't really love that because I like doing calculus. But I love that we finished another segment. We're done. Don't forget to like, subscribe, comment if there's things you want to see or just things you want to talk about problems I've done. Maybe you know a way how to do something that I don't. And if it's good enough and I think it's relevant, I'll teach it to my kids. There's no shame in learning, none at all. All right? Have a good day, and hopefully you stick around for the short answer problems. Bye-bye, my friends. Bye-bye.
Don't forget to subscribe and ring that bell.